Hello everyone, we are Team Veteran Driver. Today we are going to present a basic tutorial for MongoDB. So for MongoDB, it's like a free and open source cross-platform document-oriented database program. So classified as a NoSQL database program, MongoDB uses JSON-like documents with schemas. In addition, it supports several main features, including ad hoc queries, indexing, high availability, efficient load balancing, and batch processing by using MapReduce. So we can see someone may ask why we want to use MongoDB. So first of all, MongoDB is the most popular NoSQL database. It is a general purpose database which supports rich queries, geospatial, text search, aggregation, and MapReduce. Also, MongoDB as a document database, it keeps the balance between scalability and the depth of functionality. You can see the comparison with RDBMS in the graph. Besides the functionalities, MongoDB is easy to use and agile for programmers, and the rich query language results into less code. So last but not least, there are some examples proving that the real-life agility of MongoDB is true. You can see in the graph that the MATLAB project, by using RDBMS, it used like 2 years but failed. However, for MongoDB, it happened in 90 days and now it's still in production. So this example can prove the agility of MongoDB.
To run the MongoDB on our virtual machine, firstly, we need to set up the MongoDB environment. We download the binary files for the desired release of MongoDB. So we use the Linux version of the files. And then we extract the files from the downloaded archive. Then we copy the extracted archive to the target directory. One of the most important steps is we need to make sure that the location of binaries is the path variable. These two commands are the commands that for our downloading and extract the target, the archives. The third command is for us to making a directory in our virtual machine for store the MongoDB data. And the last command is for us to set up the path variable. Second step is we need to connect to the MongoDB in our virtual machine. So in the last screenshot, we have created a new directory in the virtual machine to store the Mongo data. And then we fire up the Mongo server by using our local host in the virtual machine. We connect to the Mongo server by using a command called Mongo. And then we create a database in our MongoDB. It is called MovieDB. And then we create a user for the current database, which is called CS511. Lastly, we create a collection in our database. The collection name is movies. For this MP, we use IMDB 5000 movies as our data set. So as you can see in this graph, there are more than 20 attributes in this data set. The most important two attributes are plus keywords and genres for our MP.
Now I'll discuss the task and the implementation details. The task is to build an application using MongoDB, which allows users to search for movies based on genres and keywords. Combined genres and keyword search should be allowed here, and our application should return all the movies which contains these words. Our dataset is an IMDB dataset, which is stored in CSV format, with each line consists of a movie and its attributes separated by commas. For example, if a user typing action killer in the search keyword, the application should return all the movies that is related with action and killer. Note here that a movie that is only related with action or only have a keyword with killer should not be returned as the result, because the search needs to match all the search words, not one of the search words. So what are we expecting to learn from this task? Through this task, we should be able to use MongoDB for storing massive data and write complex queries on it. We can also learn how to build simple applications using MongoDB as our database. I will discuss the details on how to implement this task in the next few slides. First, we want to import the IMDB CSV data file into our MongoDB database. The problem is for the attribute generis and attribute plot keywords, they are originally strings split by vertical bars, but we want them to be stored as an array of strings. Therefore, we need to do some split operation here to split them into an array. The second is to connect with MongoDB. For here, we use Mongo client to create connections with MongoDB, and we use the password and user to do the authentication. And in Java, we actually need to handle the dependency for building the application. And for here, we just use Maven to build a dependency. Before we actually implement in Java, we actually need to first understand how we should write the query. For here, we have the AND logic to support multiple word search. Because we don't know which attribute the search words belong to, we have to enable the OR logic here to allow users to search both in generis and in keywords. And the last, we use the IN logic to perform a search in array. Once we have the MongoDB query, the final step is to implement it in Java. To perform a search, we need to first create a basic DB object and put the logic and the objects in that DB object. For each logic, we create its object and add it to the outer object. Now we will show you a demo of this application.
We have fired up the MongoDB server in our virtual machine, so let's do our demo now. In this demo, I will use two keywords for the searching. The first one is for the first attribute genres. The keyword is called actions. And the second search keyword is serial killer. It is for the attribute of plot keywords. So remember, when you do the search, you have to split multiple search keywords by using comma. So this search query should return all of the documents that contains action as genre and also serial killer as the plot keywords. Let's take the last one as the example. See, action is here and serial killer is here. So it is successful. And then let's try another example. Let's try to search action by itself. So it will contain all of the documents which has genres as action, and the plot keywords can be anything. So let's take this as an example. See, action is here. And in the plot keywords, it's just some arbitrary strings. Let's try another example. Let's search serial killer this time. Let's take this as an example. In the plot keywords, see, search serial killers here. And in the genres, it can be any strings here. So now we will do some evaluation for our project.
After demoing the task details, now we are going to compare the traditional RDBMS with MongoDB. MongoDB has great advantages on scalability. In addition, this graph shows the schema of a simple IMDB database. However, it still looks very complicated as a schema. So in contrast, as an object-oriented database, MongoDB does not need a complex schema or normalization. All in all, MongoDB achieves the scalability as a NoSQL database and is very friendly to programmers. Also, we will offering something more about MongoDB features. MongoDB also supports GeoQueries for visualizing geospatial data. In addition, MongoDB's geospatial indexing allows you to efficiently execute spatial queries on a collection that contains geospatial shapes and points. So thank you for watching this video.